Hi learners, this is Brady S. Nave, your science video learning facilitator, together with the DCNHS Grade 10 Science team, especially to Ma'am Lady Luvimin Baswell, our language and content specialist, Miss Rayan May Baldoza, our video editor, and yours truly, your illustrator. Today's topic from our Quarter 1 Module 2 SLM is entitled Plate Boundaries. Hope you will learn more from our video presentation. In this week's video, you are going to learn about the different types of plate boundaries, describe the different processes that occur along these boundaries, and identify geologic features formed as a result of these geologic processes. According to the plate tectonics theory, the entire lithosphere of the Earth is broken into several segments called plates. Each plate is slowly but continuously moving due to convection currents in the mantle. As a result of the motion of the plates, three types of plate boundaries were formed. Divergent plate boundary, convergent plate boundary, and transform, fault, or plate boundaries. At a divergent plate boundary, the two plates are moving apart. The first type of divergent plate boundary we are going to discuss is the moving apart of two continental plates. We call this continental divergent plate boundary. These two plates move away from each other because of the convection currents below them. Both currents are in opposite direction, thereby causing the continental crust to undergo rifting process, which is also known as tension or stretching, thereby creating a zone of tension and forming geological feature called rift valley. And you will find a set of parallel fractures that form a graben. A graben is a valley with a distinct escarpment on each side caused by the downward displacement of a block of land. The East African Valley of Africa is an example of a rift valley which was formed due to the moving apart of two continental plates. The African and Somalian plates. If the rifting process continues, the continental rift graben continues to descend until it sinks down below sea level. The surrounding oceans or lakes may fill it with water, and it will become a sea or a lake or turns into a normal mid-oceanic ridge. This brings us to the second type of divergent plate boundary, oceanic divergent plate boundary. A mid-ocean ridge or mid-oceanic ridge is an underwater mountain range formed by the diverging of two oceanic plates due to seafloor spreading process. During seafloor spreading, a new rock oceanic crust is formed through volcanic activity, depositing new material at the ridge. As new material is continuously being added, it is slowly pushed away from both sides of the ridge and then gradually moves away toward the continental shelf. The youngest oceanic crust rock is found at the ridge. While rocks farther away from the ridge have older age. Scientists have discovered that these oceanic crusts are magnetic and follow a pattern. As the young oceanic crust rock spreads away from the ridge, it cools, contracts, thickens, and becomes denser. An example of oceanic divergent plate boundary is the MidAtlantic Bridge, located along the ocean floor of the Atlantic Ocean. This ridge has the longest mountain range in the world, and it is produced by the divergence of the oceanic plates, the Eurasian and North American plates, and also below the equator, the divergence between South American plate and African plate. When two plates move toward each other, the meeting zone is called Convergent Boundary. The first type of convergent boundary is the meeting of two softer, thick, and old continental plates. Due to collision process, both low-density continental crust will not undergo subduction. But will create a mountain range and high plateau as geological features or landforms. One of the examples of continental convergent boundary is the Himalayan mountain range, or simply the Himalayas. These mountains are formed after the continental Indian plate collided with the continental Eurasian plate. The second type of convergent plate boundary is oceanic continental convergent plate boundary. At an oceanic continental convergent boundary, a subduction process will occur. Subduction is a term given to the sinking of one plate beneath another plate. In this case, the heavier, denser, and thinner oceanic plate bends toward and it is forced to sink due to a high gravitational potential energy into the mantle when it meets an older, softer, and less dense continental plate. Regions where this process occurs are known as subduction zones. Also at the subduction zones, shallow and deep earthquakes were also created, and these earthquake zones are called the Wadati-Benioff zone. Unlike shallow earthquakes, deep earthquakes are less damaging because seismic waves from deep quakes have to travel farther to the surface, losing energy along the way. As the oceanic crust sinks deeper into the mantle, the pressure increases. At depths of around 100 km beneath the surface, water is liberated from the ocean crust of the subducting plate. The water gradually seeps upward into the overlying wedge of hot mantle, which results to partial melting of mantle rocks. Above the subducting oceanic crust, magma is formed and will slowly rise into the overriding continental plate and finally to the surface, forming a volcanic arc. Volcanic arc is a chain of active volcanoes which is parallel to the deep ocean trench. Volcanic arcs that were formed to the surface of the continental crust are called continental volcanic arcs. An example of a continental volcanic arc produced by an oceanic continental convergent boundary is the Andes mountain range running along South America's western side. From Venezuela in the north, the range passes through Colombia, Ecuador, Peru, Bolivia, Argentina, and Chile. The Andes mountain range, or simply the Andes, was formed due to the convergence of the oceanic Nazca plate and the continental South American plate. On the oceanic plate, parallel to this mountain range, a deep trench is formed. The Peru-Chile Trench, also called the Atacama Trench. The third type of convergent boundary is the meeting of the two oceanic plates. The older oceanic crust will be at the subduction zone. Due to subduction process, trench, and volcanic arcs are its geological features or landforms. Above the surface of the young oceanic crust, the volcanic arc is formed. And this will be called volcanic island arc or island volcanic arc. The Aleutian Islands of North America and the Philippine Islands are examples of convergence of two oceanic plates. As you can see in the map, the Aleutian Island arc were formed due to the convergence of two oceanic plates, the Pacific Plate and the North American Plate. Another example is our Philippine Islands. As you can see in our map, the Philippine Oceanic Plate converges with the Pacific Plate. At the same time, the Philippine Plate converges with the Eurasian Plate. The third type of plate boundary is the transform fault, where plates slide past one another without the production or destruction of crust. When strike-slip movement halts due to increased friction at some location, stresses can build up that are released in sudden slips. This may result in some of the most damaging earthquakes on a continental crust. The grinding action between the plates at the transform plate boundary results in shallow earthquakes, large lateral displacement of rock, and a broad zone of crustal deformation. Due to the shearing or faulting process in transform fault boundary between Pacific and North American plates, the San Andreas Fault in western US is transecting in the continental crust. And to summarize our lesson for today, here is the summary of table about the types of plate boundary. Let's start with divergent. The divergent between continental plates involves rifting or tension process, and its landform is rift valley. Example, the African rift valleys. The second type of divergent plate boundary is the divergent between two oceanic plates. The process involved is seafloor spreading, and its geological feature or landform is the mid-ocean ridge. and its best example is the MidAtlantic Bridge. The second type of plate boundary is the convergent plate boundary between continental plates. The process involved is collision. Its landforms are mountain range and high plateau. Examples: Himalayan mountains and Tibetan plateau. The second type of convergent is the convergence between oceanic and continental plates. The process involved is subduction. Its landforms are trench and continental volcanic arc. Examples are Cascade and Andes Mountains. The third type of convergent is the convergence of two oceanic plates. Still, the process involved is subduction, and its landforms are trench and island volcanic arc. And the examples are Philippines and Aleutian Islands. And the third type of plate boundary is the transform fault boundary between continental plates. The geological process involved is faulting or shearing, and its landform is called the earthquake fault zone. And its example is the Alpine fault. And for the second type of transform fault boundary is the oceanic transform fault boundary. Its process is still faulting or shearing. Its landform is still earthquake fault zone, and example is the San Andreas fault. Thank you for watching our video.